Hello everyone, welcome to MEMONEET. My name is Rohit. Today we will be discussing Brahmastra test for physics subject and SME of physics. So let's start our first question. Our first question is if binding energy of helium atom is 47.37 megaelectron volt, then binding energy per nucleon of the atom is given. We have to find out binding energy per nucleon. We have given binding energy. So this is a very simple question. Let's see its solution. So binding energy per nucleon is just equal to, we have to divide it by the nucleon number, and nucleon number is equal to 4. So we will get our answer for 6.84 megaelectron volt. So next question, if z equal to a a raised to power 3 b power 1 by 3 divided by c d power 3 by 2 and percentage error in the measurement A, B, C are 1%, 3%, 2%, and 4% respectively, then relative error in the calculation of Z will be. This is question related to the errors. Very simple question. Again, we have to calculate the percentage error and we have given the error in different parameters. It is very simple. We have given the value of Z, that is equal to A raised to power 3, B raised to power 1 by 3 divided by C, D raised to power 3 by 2. So delta Z will upon Z will be equal to 3 delta A upon A plus 1 by 3 delta B upon B plus delta C upon C plus 3 by 2 delta D upon B. And relative error in ABCD are given. So we have to put the value here. So we can here value of delta A upon A is 1, delta B upon B is 3, delta C upon C is 2, delta D upon D is 4. So we get 3 plus 1 plus 2 plus 6. We get here 12. So delta Z upon Z is equals to 12 percentage. So we can write it down 12 upon 100. We can write it down 1.2 into 10 raised to power minus 1. So option 3 is correct. Hope you all get it. Very simple question again. So let's move to next question. Just a second. So you can all see the solution here. I am solving it on the page. You can pause the video and see the solution. So next question. Next question is, a particle is projected from the ground at angle 60 degree above the horizontal with speed 150 meters per second. The time after which the particle moves at an angle 45 is vertical. This is a question from projectile motion. Where is the question? Just keep attention here. So we have given a projectile motion. The particle is moving at angle 60 degree with the initial velocity u, that is given 150 meter per second. So we know that horizontal component will be equal to u cos theta, vertical will be u sin theta. This is horizontal, this is vertical. We want to know that when the particle is at angle 45, at some time particle will be at 45 degree angle with the vertical. So if it is 45 degree with the vertical, then it will be uh, just making figure again. If it is 45 with the vertical, then at the same time it will be 45 degree angle with the horizontal also. So we know we will calculate the horizontal and vertical component. First of all, u cos theta, that is ux, that will be equal to, we have given the value of theta, that is 60 degree. So u cos 60, value of cos 60 is that is u by 2, u is given 150. So ux is 150 by 2 and uy is u sin 60. That is 150 root 3 upon 2. Now we want to calculate the value at 45-degree angle. So by applying the Newton's first equation, our motion V is equals to U plus AT. So here we take V is equals to Uy minus Gt. Okay. So see this vertical component at 45-degree will be equal to the horizontal component. So that 45-degree these are equal. So this component will be equal to the Vx, same time will be equal to the Ux. Ux is 150 by 2. So here it is written 150 by 2. And Uy we have calculated 150 root 3 upon 2 minus we have taken the value of G as 10 into T. So by solving these equations, we can get the value of time at angle 45. So look at this. We have calculated from here that 150 by 2 is equals to 150 root 3 upon 2 minus 10 T. Okay. So from here we are getting 115 root 3 upon. Very simple question. Easily simple calculation. Just the basic concepts of the projectile motion, laws of motion. Now we are moving to our next question. See, our next question is the ratio of longest wavelength corresponding to the Lyman and Balmer series in hydrogen spectrum. This is question from atomic physics. Lyman and uh, Lyman and Balmer series. So we know about the formula. This is formula 1 upon lambda is equals to Rydberg constant 1 upon N1 square minus N2 square. So we want the longest wavelength. We want the corresponding to the longest wavelength. So for Lyman series, this N1 is equals to 1 square, N2 is equals to 2 for the longest wavelength. From here, we will get the relation of lambda. Lambda that will be is equals to that we will get 1 upon lambda r LCM. We have taken 4 minus 1 that is 3 r upon 4 1 upon lambda that is Lyman. Similarly, we get the value of Balmer series. So for Balmer, 1 upon Balmer is equals to R, 1 upon for Balmer longest wave is corresponding to N is equals to 3. From here we get the value that will that is the simple calculation. Take the LCM 36, 9 minus 4, go to the constant 1 upon lambda Balmer that will be equal to 5 upon 36 R, 1 upon lambda. Now we have to take the ratio. Just keep attention here. In which term we have to take? We have to take ratio of Lyman and Balmer. So 1 upon so lambda Lyman upon lambda Balmer. So from here we get the value of the lambda Lyman. Lambda Lyman will be is equals to 0.3 r divided by 1 upon lambda Balmer. Balmer is equals to 5 by 36 r. So by solving we are getting 5 upon 27. So our option is 2 is correct. Okay. Now moving to our next question. Hope you are getting all these things. If you have any doubt, you ask your question in the comment section. So let's move to our next question. Next question is an object starts from the rest and moves along a straight line with the constant acceleration a for some time and comes to rest with the uniform retardation beta. Alpha and beta. Alpha is given in the acceleration, beta is given as if total uniform distance traveled is d, then time taken for the entire journey. See, We have given an object that starts from the rest. We'll solve it graphically. See the solution here. Acceleration. What is acceleration? Acceleration is uh, we can find out it by the velocity time graph. Slope of velocity time graph will give you the acceleration. This particle has a constant acceleration. Hence, the alpha and the retardation beta. Now, what is given? If the distance traveled is d, then time taken for the entire journey. This total distance is d. So we have to calculate the time taken for the journey. Suppose the time taken here is t1 and time taken for this retardation period is t2. Okay, so here is v maximum, this is 0, this is distance d, okay, this is t2, this is t2, this is t1. So actually the if the total uniform distance traveled is d, the distance d, distance is this one, this one. So time, let's suppose t1 is for acceleration, t2 is for retardation. From here we can calculate, take slope of this this graph. You can see my pencil. So its slope will be is equals to acceleration. We know that slope of velocity time is acceleration. So slope will be is equals to v minus 0 upon t1. From here we can get v upon alpha. Similarly, for this retardation period, we can calculate the slope. The slope will be is equals to, because the negative beta is the negative slope. So take the sign, take this sign is negative and slope 0 minus v upon t2. So from here we can get t2 is equals to v upon beta. So total time will be t is equals to t1 plus t2. So v upon alpha plus v upon beta. So from here, I am reducing these things. From here, we can get t is equals to v upon alpha plus v upon beta. Then uh, we can get v is equals to, just a minute, these things. Alpha beta, take it as a LCM. We have v beta plus v alpha. T is equals to v alpha plus beta upon alpha. Okay. Now we know that from here, this distance, we can calculate the distance. This distance is actually the area under the graph. Okay. So area under the graph is half base into height. So base is total time t and height is v naught maximum time. V naught maximum time. And we have calculated this time. So put the value here. Then we will get this relation d is equals to half alpha beta upon alpha plus beta into t square. And from there we can find out the value of t. Simple. So hope you get this answer. This is just simple calculation we can do simply from the graph of the velocity time for the acceleration, and remember, slope for the acceleration is positive and retardation is negative. That is very important point here. So let's move to our next question. Question number 6. So what is question number 6? The force acting on the body of the mass 5 kg lying on the rough floor with the coefficient of friction zero point 0.4 between is given 5, F is equals to 5 to square plus 2 Newton, and the time when the body will just start the moving the floor. We have to calculate the time when this body starts moving. So this 5 kg, it's experienced the force F is equals to 5 t square plus 2 Newton. So there will be an mg force, there will be a normal force acting in upward direction, and the friction force that will be in this direction, that will be this friction force will have the mu n, that is n is normal force, mu mg, value of this friction. And we will equate this friction force with the value of the force because these are in opposite direction, so they will balance each other, and from there we can get the value of our time. So see here what we are doing. This F maximum is equals to mu mg. Mu is given here 0.4 and m is given here 5 kg, and g we have taken the 10, so we get the value here as 20. This is the value of mu mg. This is 20. And value of f 5t square, 5t square plus 2 is equals to 20. Take 2 here. On the other side, we get the 18, t square is equal to 18.5, and then we get the value. We have desired value. This is option number 1 is correct. Hope you are getting all these things. Very easy questions. These are simple and the basic concepts just. So keep revising. Next question. Very good question. Keep attention. A uniform rope of length L lies on the table. If the coefficient of friction is mu, then the maximum length L of the part of this rope which can overhang from the edge of the table without sliding down. See, what is asking here, what is given here is that there is a rope. See at this figure in the solution section, there is a rope. Its total length is L, and some part of it is hanging. Suppose we have a table and on we have a rope of length L, and some part of it is hanging downside. Okay, this, and we have taken this part as X. So remaining part that is on the table is L minus X. Okay, now we have to calculate the max. We have to calculate the maximum length L for which the overhang from the edge of the table without sliding down. We want to calculate that. We have to given situation that if it is hanging like this, we want to calculate of this X length such that it will not slide down. Okay. So suppose we have the mass of this rope is m. Then, and we have taken this as x, the part that is hanging. Okay. So L length have the mass m. Then unit length will have the mass m by L. So x unit of the length of the rope will have the mass m by L into x. Hope you are getting this point. This is very conceptual problem. Similarly, for the L minus x, the mass is m upon mass is m upon L upon into L minus x. We will use these later. See here, this weight of the chain, that is m x upon L. This length, this chain that is hanging. See, for the rope to not slide down, without sliding down, it is on the table. See, what are the forces acting here? There is a contact with the surface, so we have a normal force that is upward direction. Then we have a downward direction, mg. Same here, that is mg. There will be a friction force that will be F, that will be equal to the mu mg, mu normal force that will be mg. So that is here the W is equal to Fs max friction, that is maximum, then mu S into M. Then this will be equal to the, this will be balance out this force that is acting on the L minus X part. The force, the tension that is acting on this part, that will balance out this part. So we have made this thing here, mgl mg upon L into X is equals to mg upon L into L minus X. And from here we can put the value of, we have cut down the M and G, and then we get X upon L is equals to mu L minus X uh, divided by L. Then from here we will solve these equations, and then we will get, the value of X. And the value of X that we are giving is X is equals to mu L upon L plus V. This is option number 3. Okay. Just balancing out the force, nothing else, because this friction force will balance out with the tension force that is acting, that is taking this rope downward. So this friction will balance so that it will not slide down. Okay, and at this part, hmm, and in this part, that is for L minus X, this is X part. So we have balanced out these forces, this tension force and this friction force, nothing else. I hope you are getting all these things. Moving to our next question. A body of mass 1 kg is thrown vertically upward with speed of 20 meter per second and returns back to the earth with a speed of 16 meter per second. The work done by the air drag is. See, this is the question related to the work energy and the motion. So we have a mass of 1 kg and we thrown it upward with a speed of 20 meter per second. So look at the solution. At the maximum height, when we throw it at maximum height, its velocity, final velocity will 0, because suppose I have thrown this object upward, sometime it have the maximum velocity 0, then it comes back. So using the third equation of laws of motion, v is equals to u square plus 2as. Here the final velocity v will be equal to 0, and u we have the initial velocity that is 20 meter per second, and acceleration is in the opposite direction, that we will take the minus g gravity, and we can attain the maximum height. So from this relation we will get u square plus 2as is equals to 0. U is 20 square plus 2 minus 10, that is h is height 0. 400 minus 20, h is equals to 0. H we get here 20. This is the height that object will reach when we will throw with the velocity of 20 meter per second. Okay. Then what is asking the question is the work done by the air drag and returns back to the earth with a speed of 16 meter per second. Work done by the air drag. Now the working by the air drag will be kinetic energy minus potential energy. Total energy is kinetic energy plus potential energy. Suppose this object is coming downward, so its kinetic energy is increasing, but its potential energy is decreasing. So we have taken here negative of the potential energy. So kinetic energy, we know that half mv square. Kinetic energy, we know that half mv square. And given that mass is 1 kg and now it is coming with the velocity of 16 meters per second, we have put here 16, and m is mg, potential energy is mgh, m is 1. Gravity, we have taken g, value of g, gravity acceleration is 10, and height we find out here, that is 20. We will put here, then we will get the answer 128 minus 200 joule, that will be equal to 72 joule in the negative. So main thing is the concept here, that when the object is coming downward, kinetic energy is, see here the velocity is 0. Now it is coming downward, so it will both have the kinetic energy plus potential energy. But when it reaches ground, its potential energy will 0. At that height, so its potential energy is decreasing, and when it is moving, it has the kinetic energy. That is simple question. Now moving to our next question, ninth question, very conceptual question. See, this is very important question. Nine. Just a minute. A circular plate of radius r by 2 is cut from the edge of thin circular plate of radius r. You have given a radius r plate and said that there is a circular plate of radius. Its radius is r by 2, that is cut down. So the moment of inertia of remaining part through this O and perpendicular to the plane of the plate. You have to calculate this remaining part moment of inertia. Oh, sorry. Remaining part moment of inertia. So, this is just a conceptual question. Look at here. This circle, this we have cut down the r by 2. Circle, we have cut down the r by 2 plate from here. This radius is r. So we know that the moment of inertia of whole is mr square upon 2. That is original. Mr square upon 2. Now we have cut down. We know that this r radius have the mass m. So this r by 2 plate will have the mass m by 4. You can see from the figure, this r by 2 mass have the mass m by 4. So this cut down part will have the moment of inertia, that will be mr square upon 2. M is m by 4, r is r by 2, m, sorry, it's not square, m r square upon 2. So we will get it from here, m r square upon 32. Now we want this is the moment of inertia at its center. Now we want the moment of inertia at this point. So we can use the theorem, parallel axis theorem. So we can add down the moment of inertia. So mass is m by 4, distance is r by 2 here. So we will get here 32 c m r square. This is the moment of inertia at this point from this small part. So we can subtract this small part from the bigger part, and we will get the remaining moment of inertia at center O. So it will be mr square by 2 minus 3 by mr square minus 32. Okay, then we will get the answer here as 13 by uh, we will get the answer 13 by 32 mr square. Simple, just that have been raised. You can just I can see that how I am done. This is the concept in which we have used the parallel axis theorems. So keep remember those theorems, parallel axis, perpendicular axis, important questions. Now, next is 10th question. A metal wire of the length 6th area cross section 2 Young modulus given there behaves as the spring of the spring constant K, the spring constant K. It has given that there is a metal wire and given the Young modulus and it behaves like the spring. The spring constant is K, so value of the spring constant. So we know that for the spring, F is equals to K delta X. You know that X, F is equal to Kx, X is elongation in this spring. Uh, X is the elongation in the spring. And for the Young modulus, we know that stress upon strain. So these have a relation between them. That relation, how we find out those relation? See, Young modulus is stress upon strain. So stress is force upon area. Strain is change in this length. We can get FL upon XC. And we know the spring constant is F is equals to Kx. From here, K is equals to F by X. So Young modulus we can get K L upon A. So from here, K L upon A. This relation. From here, we can get the value of K that is equals to YA upon L. And all these parameters we have given in the question, we can find out the value of K. See this Y value of the Y, that is 3 into 10 raised to power 9, and area is 2 centimeters square. So look at the units. We have a length in meter, cross section is centimeter square. So convert in the standard units meter. So we centimeter square. So we multiply with 10 raised to power minus 4 and divided by length, that is 6. So we come down this, we will get 10 raised to power 5. So here it is written 100 into kilo Newton per meter. So we will get our answer. Simple things, just easy, just a formula and simple concept. So if you can't remember, so learn this concept of how we get this formula. Okay. Second, now next question, 11. Two capillary tubes of same length L. Two capillary tubes of same length L, but radii R1 and R2 are fitted parallel to the bottom of a vessel. What should be the radius R single tube some same length that can be replaced two tubes so that the rate of flow is same. So this is from the fluid chapter, and this is very simple question. Actually, it is a conceptual, and we have to remember the formula for this question. Actually, we have given the two capillary having the radius R1 and R2, but having the same length L and L. So the rate of flow from these capillary, we have the formula that is P upon 8 neta L upon pi R1 to power 4. This from one capillary. From other, we have P upon 8 neta L upon pi R2 to the power 4. So from these, we get this relation. So we want a capillary of the radius R such that the flow will be same. So that will be, so suppose we have this capillary of radius R, then it will have the flow R raised to power 4 upon 8. So we want such that this flow and sum of this flow will be equal. So all these things are constant. We will equate these to equation, and all these things are equations. So we get R raised to power 4 is equal to R1 raised to power 4, R2 raised to power 4. That is option number 1 here. Okay, so we have to remember this formula. Okay. Now next one is 12th question. Uh, this is the four identical nodes of the same material connected between the node A and B maintained at the temperature 20 degrees Celsius and 100 degrees respectively as shown in figure. So such type of question you can solve it easily, like we have given a rod and points A, B, here it is C, and these are 1, 2, 3, 4. This is a rod having the four parts. So just a minute, I will draw it again. A rod A, C. These are the four rods of the same material connected between A and B point, and A point have the temperature 20 degrees. B point have the, so we want to calculate the temperature of the point C. So we can solve these questions with taking analogy with the electrical circuits like this. We have this point A, we have this point B, and we have these four rods. So we can take it as identical resistors, four resistors, because these are identical, so they have the same resistance. So they first connect the four resistors. These are four resistors. These are four identical so materials. So we have the four same resistance. And this is the our C point where we want to calculate the temperature. So taking it analogy with electric circuit, it is becomes very easy. We have given the like here the 20 and here given the 100. And now simplify it, and we will get these are all in series. 3R, this point C, this is R and B and A. So 20 is going to be 100. Now we can use the node law in which the current I1 is equals to the current I2. So then we can take it as, suppose it have the x value here, x potential values. So 20 minus x upon 3r, that will be equals to x minus 100 upon r. So r to r cancel, then we will get 20 minus x is equals to 3x minus 100. So we get 4x. We will get, just a minute, 20, because current is we are wanting, we can solve it by taking the analogy with the electrical circuits. Where it is the value of x. That is temperature. We want to find temperature at that point. We have taken the analogy with electrical circuit. It becomes easy for us to solve these questions. In solution, it is given with the concepts of thermodynamics. So basically, you can solve it in these questions. In complicated situations, we can solve the circuits very easily. So go with this. Okay. It is the amount of the heat required to raise the temperature of the 10-gram liquid from the 0 degree to 10 degree. Specific heat in the calorie with the temperature as point. Specific heat is given 0.3 T square. We have to calculate the amount of heat. So it has just a simple formula, that is MC delta T. See here. DQ is MC delta T, given the M 10 gram, CV given 0.3 T square and dt. So Q will be is equals to, you see here, MC dt, we have given 0.3 T square, we have given the M value. So we get the t square dt. We will integrate from where to where? We have given the value of t, that is 0 to 10. So we will put the value here 0 to 10. Then we will get the answer, that is 1000 calorie. Simple question, just a simple formula of the heat mc delta t. So remember these formulas. Now moving to next question. A certain mass of the gas at 273 Kelvin is expanded to 8 liter times its volume under the adiabatic condition. Gamma is given. This gas is expanded in the adiabatic condition, and given we have given the value of the gamma, and we want to calculate the final temperature. So for we know that for adiabatic processes, the T V gamma minus 1 is equals to constant. So from here we can T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1. And we want to we have given the temperature 273, which have the volume V. Suppose we have initial value V and final volume is 8 times V. We have given the value of the gamma, initial temperature 273 Kelvin. We have want to calculate this T2. So simply equate this and put the value here. So we get the T1 upon T2, that will be equal to V2 upon V1. V2 upon V1 raised to power gamma minus 1. Gamma value is 1.25 minus 1, that will be V2 upon V1 raised to power 2.25. We have V2 is 8, 8V, V1 is V, 8 raised to power 0.25, and temperature T1, that is 273. So we will get the answer in 91 Kelvin. So converting it in the degree Celsius, we have to subtract 273 from it. Remember it, because we have given option in the degree Celsius. So we have to subtract 273 from here, and we will get 182 degrees Celsius of negative. Okay. Now moving to the next question, 10 number question. The particle is moving along the x direction with the influence of force given, that is F is equal to minus 5x plus 15 at time t equal to 0. It is located at x equal to 6, having a zero velocity. It takes 0.5 seconds to reach the origin for the first time equation of motion. We have given the force, that is 5x plus 15. So we can find the mean position of the particle by equating it to the 0. See here, mean position can be equated to the 0. So we will get the mean position of the particle, that is 3, x equal to 3. And we see that at t equal to the particle located at x equal to 0, having 0 velocity. So at x equal to 6, it has the 0 velocity. This is the extremum position of this, and it again goes in this direction. So mean position is this 3. So it will go till O, right, origin. So from this mean position to this extremum position, this uh, will have the 3 unit, that is equals to the amplitude. This is amplitude, and it is given, it takes 0.5 second to reach the origin for the first time. From here to here, from here to origin, it takes 0.5 second. So then again it will take 0.5 more. So t by 2 is 0.5. So t will be equal to 1 second. Okay. Now for the equation of motion, for the equation of the motion of the particle, we know that general equation of motion is equals to x is equals to a sine omega t plus phi, that is phase. And here also the phase will be equal to pi by 2. Here it is 0, then again pi by 2, then again pi, then pi, then pi by 2, and pi, like this. Okay, phase will be here at, this is pi by 2. So at mean position x minus 3, that is equals to amplitude A sine omega t plus pi by 2, that is phase difference. So x is equals to 3 plus 3 sine 90 plus theta, that will be equal to cos y. This is our equation of motion. After getting all these things, now next 16 number question. From gravitation, the height at which the acceleration due to gravity becomes g by 9 in the terms of radius. C. The value of g is gm upon r square. And suppose we want to calculate the value of g at some height, g dash. So we can use the formula. We take this for gm upon r plus h here. Suppose we want to calculate that h, some height h. Given it here that the acceleration due to gravity becomes g by 9 in the terms of r, where r is the radius. And it becomes g by 9. Means at h height, this becomes, this g dash is become g by 9. So gm upon r square equal to gm upon r plus h square. From here we get 9 r square equal to r plus h square. Taking root, so 3r equal to r plus h. H is equals to 2r. Simple question. Moving to the next question. Question number 17, statement question, conceptual question. An astronaut experienced the weightlessness in space satellite. This is assertion. C. And next is reason. When the body falls freely, it does not experience gravity. So, what is the correct answer here? Both assertion and reason are true. Reason is the correct expression. C. The correct answer for this question is option number 1. The both statements are the true. Why these are true? See, when the satellite will revolve on the Earth, it will have some centripetal fluid force MVR that will balance out with the gravity. Okay, so these forces will balance out each other. So that's why the experience the weightlessness condition, experience the no change in acceleration. So no that is acceleration is in this condition, that is balance out mv square upon r, and balancing out here gravitational force. The net acceleration is zero, so that is why there is no force acting on it. So it will have the acceleration and condition of the weightlessness. And when the body falls freely, it does not experience the gravity. See this explanation. The centrifugal force in the rocket frame reference the balance of the gravitation acting on the astronaut, hence the normal to the astronaut is zero. Because this centrifugal, I have told you, this centrifugal force will balance out the gravitation force. So there will be no normal reaction. That's zero. So it feels the weightlessness condition. Because it feels the zero reaction, the both satellite and astronaut are the under the free falling condition. Because they are in the weightlessness condition. See, when we feel the weight, we have the gravity G, this gravity is pushing downwards, so we experience the energy force. Here in the condition of weightlessness, they feel like free fall body. Both assertion are, these are true. Now, next question. 10th question. A charge Q is divided into the two conducting spheres. What should be the value of the charge in the sphere? Show that when placed a certain distance apart, the repulsive force between them is maximum. Suppose we have the solution. Suppose we have the charge Q on one sphere. It has the one. We have total charge given, that is Q total. This is total. So this charge will left down with Q minus Q. Now the force acting between them, so their distance r, that will be equal to the k q minus q divided by r square. This okay. Now for the maximum to calculate the value of the maximum, we will calculate df upon dq. By calculating the df upon dq, we will get the extreme condition. So see this, we have calculated here the df upon dq, that will be equal to kq minus 2q. For the maximum condition, we put it as 0. So we get that 2q minus 2q is equals to 0, q is equals to uh, q is equals to 2q, and capital Q is equals to q by 2. Q by 2. So option number 2 is correct. Q by 2. Q by 2. Simple question. Just derivative with respect to the variable charge variable, that is capital Q here. So we are taking it question. The given charge is the constant. We have taken this variable here is capital Q. So we derive with respect to that, and we get the value of capital Q, that is Q by 2. It means that we have to divide the whole charge in half R. Now next question. The total reactive flux emerging from a closed surface enclosing the proton. See this. The formula of flux is E dot ds, that will be equal to the Q upon epsilon naught. This is Gauss law. So for the proton, the Q is E on epsilon naught. This is simple question, very simple. Gauss law basics of the code. Simple question, basics of electrostatics. Gauss law we can solve here. Next, from the electronics, the charge deposited on the 2 microfarad capacitor circuit is C. First of all, we calculate the total capacitance of the C circuit. See, this 6 and 2 are in the parallel. So in parallel, we will add them up. So these two will have 6 plus 2, that will be equal to 8 microfarad. So this 8 microfarad and this one, this 8 microfarad, they are now in series. So if they are in no series, so we can, because they are of the same, because they are same magnitude, 8 and 8, so we can divide by 2, we will get the 4 microfarad. Total capacity equivalent is 4 microfarad. So we know that Q is equal to CV. So from here we can get the value of Q, that will be equal to the 4 microfarad into, that will be equal to the 4 microfarad. Q equal to CV, 4 microfarad into 12 volt, that will be equal to 48 microfarad. That is, here it is calculated. See. Now suppose this charge, see, this charge, some charge will go in this capacitance, some charge will go in this capacitor. Suppose here it goes Q1, so remaining charge will be 48. Here it is given Q1, so remaining charge will be 48 minus Q1, and these are in the parallel. So in the parallel, they will have the same voltage. So Q is equals to CV, so V is equals to Q by C. We have this relation, V is equals to Q by C. So from this relation, this capacitance 48 by Q1 upon this 6 microfarad will be equal to, this voltage difference will be equal to the Q1 upon 2 microfarad. So from here we can calculate the value of the Q1, the charge on this capacitor, that will come out 20 microfarad. Simple question, just we have to calculate first of all the equivalent capacitance, then we will divide the charge, and because these are in the parallel, these both are in the parallel capacitance, so this voltage will be same. Okay, this formula is yes. Now next question, it is 21st question. Let an electric current pass through the circuit containing the two wires of the same material connected in the parallel. Given the two wires that are connected in, suppose these are the two wires, these are connected in the parallel. Two wires having some resistance are connected in the parallel. length and the radius of those wire are given the ratio. Suppose L1 upon L2 is 5 by 4 and R1 upon R2 is 2 by 3. That is given. Then ratio of current passing through these wires. Ratio of the current, we have to find out the I1 upon I2. Here, see, these are parallel. They will have the same voltage. V is equals to IR. This will be the constant because the value will say. So I will be inversely proportional to the resistance. Okay. So I1 upon I2 is equals to the R2 upon R1. We know that R is equals to rho L upon A. A is pi R square. These are the constants. So R is equals to the L upon R square. From this relation, we can get R1 upon R2 is equals to R1 upon R2 is equals to L1 upon R1 square into R2 square upon L2. So we have given the value of L1 upon L2 and R1 upon R2. L1 upon L2 is 5 by 4. R1 upon R2 is 2 by 3. 2 by 3. R1 upon R2. 2 by 3. That is whole square. We will calculate here 5 by 4 into 9 by 4 multiply 16 and 16 upon, because this is the value of R1 upon R2, and I1 upon I2 is equals to R2 upon R1. So we will get the 45 upon 16. This is our answer. Simple question, just using the formulas, because here it is given that these wires are connected in parallel, so the voltage across the parallel wires are same. Okay, remember the concept, voltage across the parallel wires are same. So next question, 22nd. See, the resistance of the platinum wire at 0 is 2 ohm and 6.8 is this temperature coefficient of the resistance wire. See, this is the formula. R is equals to R naught 1 plus alpha delta T, T minus T naught. This is the formula of the resistance at some temperature T and 0. So at temperature T, it has 6.8 and 0, it has 2. 1 plus alpha. We have to calculate this alpha value of the alpha temperature coefficient. Temperature is 80 minus 0. We can calculate from here divided by 2, 3.4. So we will get here 3.4 minus 1, 2.4 divided by 80, that is alpha. So we can get this simple. Just we have to put the value in this simple formulas. One line question. Next, what is the equivalent resistance between the point A and B in the circuit given below when the switch S is open and closed or respectively? See, these are the questions we have to draw the circuit very carefully. This is point A. We have to calculate when the switch S is open and S is closed. Equivalent resistance. This is point A and this is some point B. It is connected here 6 ohm resistance with A. Then see, from this end it has connected 12 ohm. This is 12 ohm and connected with some wire. This is some wire. They are connected each other. And from B point there is a resistance 12 ohm, and here there is some resistance 6 ohm, and they are connected with same wire. So this 6 ohm, so this 12 ohm and this 6 ohm become parallel. This 6 ohm and this 12 ohm becoming parallel. So now we can solve it easily. We know the formula. 1 upon R is equals to 1 upon R1 plus R2. Okay. So these are in parallel. We get the value 4. These are in the parallel. We get the value 4 ohm. These both are in the series. So 4 plus 4 is equals to 8. Now next, when switch S is closed, whole the circuit is same, but just thing is that this switch S is now closed. between A and B. So one more resistance between directly connected between A and B, directly connected. So we have connected here, this is directly connected one more resistance with of 8 ohm with the point B. So this upper circuit is same. We have calculated for this. This we will get 8 ohm and one more resistance of 8 ohm. These are in the parallel, so 8 by 2 that will become 4. Simple question. Just analyze the figure, keep calm, and see the figure. Then you will solve it easily. Now next question. Return of the mass under the action of the magnetic field moves in circle of the radius at the speed displays this, and the proton of mass want to move the circle the same radius in the same magnetic field, and its speed will be. We know that when the charge moves in the magnetic field, then QVB is equals to mb square upon r. From here, we get the value of mb is equals to QBr. Okay, because here it is given that magnetic field is the same, radius is same, so we want to calculate the speed, this mass of electron, and these all the constant. So ME can be equivalent to the ME we can calculate by this relation. We have given the value of the mass of electron, velocity of electron, and the mass of the proton, so we can calculate the velocity of the proton from here. Simple question. Just from the relation of the magnetic field, that in magnetic field the QEB is equals to the occupated force mv square upon r. Now next, these circular concentric wire of the radii A to A are carrying the current 3I to I and the same manner the magnetic field is the common center. Because they are we want to calculate the by the whole three wires, so that will be the sum of these three magnetic field due to the three, and due to the one uh, we have at center, that will be equal to the mu naught I upon 2r. So see here, first one have the 3I current and A radius, you get this. Second one have the 2I current and 2A radius. Third one have the I current and 3A radius. No, 3I, no. So add them up, we will get the answer 13 mu naught I upon 6. Simple question, just the formula based question. Now next, a current I is equals to 10 sin I is equals to 10 sin is passed in the first coil, which induces a maximum EMF of 5 volt. In the second coil, the mutual inductance between the coil. Given that I is equals to I naught sin omega t, we know that is alternating current. Given here is 10 sin 100 pi t. So from here, I naught is equals to 10, omega is equals to 100 pi. And EMF also is given that EMF is equals to 5 pi. We know that this EMF is equals to nothing, is equals to the m di over dt. Sorry, it is here mentioned wrong. That's not, this is EMF. And we know that I is equals to I naught sin omega t. So m d by dt, I naught sin omega t. The differentiation we get I naught omega cos omega t. Now put out the value of these all we have given. We want to calculate m EMF, that is 5. I naught we know that 10. Where we know that 100. Then cos omega t, for the maximum value, the cos omega t will be equal to 1. We get the value of the m from here, that we are getting 5 millihenry. The pi to pi cancel, 5 into 10 is 12 minus 3. So that is 5 only. Because we are taking for the middle, so the cost for the maximum is the 1. Now next question. 27 question. The phase difference between the flux linkage induced during rotating coil in uniform magnetic field. We have to calculate the phase difference between the flux and the induced EMF. Because we know that the flux is equal to BA cos theta, B dot A, BA cos theta, and EMF is minus d phi over dt. So we have differentiation this BA cos theta, so we get BA sin theta d theta over dt, and BA we can write down sin theta as cos 90 plus theta. So in phi and EMF we can see the phase difference of 90. So this 90 is equals to pi by 2. So option number 1 is correct. Now 28th question. A 50 Hz source of 20 volt is connected across the R and C shown in the figure. Voltage 12 volt across the R and voltage across the C we want to calculate. So for the RC circuit, we know that given frequency is 50 Hz, voltage voltage source is 20 volt, voltage is 12 volt. For RC circuit, the resultant voltage is equals to VR square plus VC square. From here, we can calculate V square is V is given, that is 20. VR square is 12 square plus VC square. We get 400 squaring both sides. We get 400 minus 144, that is equal to VC. From this, we get VC square. VC is equals to 16. Simple question. There's the concept that this is the RC circuit, so the resultant voltage will be VR square plus VC square. Now, 29th question. Electron wave is propagating in vacuum along the z direction. Propagating in direction k cap. Z direction k cap, and electric field component in the x direction. E naught sine omega sine kz minus E naught sine kz minus omega t. That is Ex. So then magnetic field component. See, the magnetic field component will always be perpendicular direction of propagation and electric field. Electric field in x, direction of propagation in k. So magnetic field be in the y direction. So see the option here we have the option of dy, the three options of dy. Now we know that we will get we know. Okay, this is answer the option number. Now, question number 30. If the polarizing angle of the piece of the glass for the green light is given here, the polarizing angle 54, and the angle of the minimum deviation for the equilateral prism made of the same glass. See the solution here. We have given the value of the polarizing angle. So from this principle of polarization, mu is equals to tan theta polarization. So we have given the value of the tan theta, that is 1.414. Value of mu is 1.414. Now we have given the equilateral prism. For equilateral prism, the angle of prism is 60. Because equilateral triangle, equilateral we know that 60 degree. And from here, now the formula of the mu for the prism, mu is equals to sine A plus delta by 2 on sine A by 2. We can calculate the deviation angle, angle of minimum deviation. We will get the value of angle A sine 60 plus delta. 960 by 2. This is 30. This is value of mu is 1.14. Sin 30 is half multiplied by half equal to sin 60 plus divided by 2. So by this we can calculate the value of delta. Simply just simplifying these things, we can get the, because here we get 1 by 1 root 2, the value of sin 45 is 1 upon root 2, sin 45 equal to sin 60. So we can get 45 equal to the 60 plus delta by 2. So now solving, we get 30 degree. So option number 4 is right. Now question number 31. When unpolarized light of the intensity I naught is incident on the polarization, the intensity of light which is not yet transmitted. See, from the Miller law, the I is equals to I naught upon I naught cos k theta, I naught into cos k theta. When the incident on the polarization, when it is incident on the polarization, then it intensity of polarized light is I naught upon 2. So so remaining part is I naught minus I naught upon 2, that equal to I naught upon 2. So half remains unpolarized. This I naught upon 2. Option number 3. Now moving to the next question, 32. The plane mirror is inclined to the horizontal at the 60-degree. A ray of the light is incident on the mirror at an angle 30 degree as shown in the figure. Angle made by the reflected is horizontal. See, this angle is 30 degree. It is incident. Here it is not. So reflected angle will also become the 30 degree. This is 60. So this normal is 90. So this angle become remaining angle become 90 minus 30, that is 60 degree. So from this geometry, this is alternating angle. So these are the parallel. So there will be no difference. So there will the difference between the angle made between the reflected ray and the horizontal will be 0 degree. These are the parallel angles. That's why. This is simply a geometry question, very easy question. Now next question 33. N-type semiconductor has the resistivity of the 1.5 ohm meter at certain temperature. If the given sample is intrinsic chemical density we have given, mu e value, mobility given, then hole concentration. See, we have the formula here. See, we have the formula here. Rho is equal to 1 upon sigma. This is the formula. Because we have given n-type semiconductor, so we can calculate this whole part because it will have the majority of the electrons. We can neglect this. So we will get rho is equals to 1 upon NEE mu E. And we have given the value. From here we can find the value of NE. So 1 upon rho E mu E, we have given these all values. So we will put the value, then we will get. See, here we have given the value in the centimeter cube. So we have to put it in the meter cube. So for the centimeter cube to the meter cube, we can multiply it by 10 raised to the power 6. Remember this. Okay, this is important. So we calculate here in the meter cube. Then from the law of the mass action, we just know that NH is equal to NE into NH. But here we can get the concentration of the moles. These are the calculative questions you have to do by hand. We need practice for these. 34th question. There is a question from the logic gate. We want to know that what is the gate for the output. See, this is A B input with the NOR gate. So this output will be A plus B whole bar. And going in the both input, then again it is NOR gate, but having the two same input, then it acts as a NOT gate. See, we will get here A B bar plus A plus B bar whole bar. So it will become A B double bar, that will be equal to the A B, A plus B. Then we have the NOT gate, then we again get A plus B whole bar. So this output is for the NOR gate. Okay. Simple question, very. Next is 35. An electron accelerated through a potential difference of 4.9 collides to the mercury atom and transferred it to the first excitation. And the value of the photon corresponding to transmission from ground state is C. This energy is equals to E is equals to H. For the applied potential EV, HC, we can write mu to HC upon lambda. So from here, lambda is equals to HC upon EV. We know the value of Planck constant 6.6 into 10 to the power minus 34 during the second. Given the value of this, you know, 10 to the power 8, and we know the value of the electron number 6 charge, and we have given the potential 4.9 volt. So we can calculate the value of the lambda from here. The answer is coming 2530 Armstrong. Option number 3. Now next question, 36 question. The dimension formula of Planck constant. We know that the Planck relation E is equals to H. From here, H is equals to E upon. So for the dimension formula H, see, dimension formula energy is mL2T2, and dimension formula of the frequency is T minus 1. T minus 2 here, and T minus 1. So here we get T minus 2 plus 1, mL2 T minus 1. This is the dimension formula of Planck constant. So you can match it with the options. Now next, 37th question. If freely falling body covers the half of its total distance in the last second of its journey, then time of fall will be. The question is saying that there is a freely falling body. The question is saying that there is a freely falling body that cover its half of distance, means h by 2, in the last second. So it take time t. So in last second, cover the h by 2 distance. So for the freely falling body, from second equation we know that s is equal to ut plus half it is square. So from freely falling u is equals to 0, so we get s is equals to half ut square. This is, suppose we have a total height h. This is equation number. Now for the half height at this time, suppose from here to here it takes t. Total time, suppose total time is t. So in the last second, we can calculate the time, calculate for the t minus 1 second. So that will be h by 2 is equals to half gt minus 1 second. So we can put the value of h from equation 1 to in the equation 2. Because it is given in the question that in the last second it covers the half distance. Suppose total time it takes t. So in the last second means in, suppose in the rest t minus 1 time it covered the h by 2 distance, and in the last 1 second it covered the next h by 2 distance. So from there we get this second relation. So from there we put the value of the h from equation 1 to the equation here, half gt square divided by half, that will be equal to half gt minus 1 whole square. G cancel, 1 by 2, so 1 by 2 cancel, t square by 2 is equals to t square minus 2t plus 1. So t square by 2 minus 2t plus 1 is equals to 0. So t square minus 4t plus 2 is equals to 0. From here we get t is equals to, solving this quadratic equation, we get the solution 2 plus root 2 and 2 minus root 2. Because for the last second, this value is less than 1 second. So we can not take this value. So t 2 plus root 2 seconds is right. So last half, distance is covered in the 2 plus root 2 second. 2 minus root 2 is very less than 1, so we cannot take this value whether it is given that in the last second we are calculating. Okay, now next question, 38th question. 39th question. The spherical body of diameter d is following the viscous medium. Its terminal velocity will be proportional to C. We have a material. We have this. We have this spherical body of diameter d. It is falling in the viscous medium. So what will be its terminal velocity? So in the viscous medium, the viscous was 6 pi neta Vr, and this is the mg. So for the terminal velocity, these all are the equal. That will be mg. From here, 6 pi neta Vr mg. We know that density is equal to mass upon volume, so we can write it out because this is the density of raw material and this is the density of viscous medium. So rho minus sigma into volume on g. So volume we can write it down 4 upon 3 pi r cube. Now put 2r equal to d because all the options are in the terms of the diameter. So then when we put 2r equal to d, then we get this terminal velocity proportional to the d square. Simple. This viscous for 6 pi neta Vr. This is mg. So we have to balance these things. Simple question. Next question. 39. A simple pendulum. A simple pendulum is oscillating in the air has the period of root 3 seconds. If it is completely immersed in non-viscous liquid, have the density 1 by 4 of the material of the bob. New period will be. New period will be. C. This T effective is inertia proportional to the G effective. Okay. This T is sorry. This T is inversely proportional to the G effective because we know that for the liquid this G is equals to the G1 minus rho or liquid rho of the material. Okay, so we have given that the density of the liquid is 1 by 4th of that material. So G of liquid will be equal to the 3 by 4 of G. So G is equals to 4 by 3 of G liquid. Okay. So T of air upon T of liquid will be equal to the G of liquid upon G of air. So G of liquid is 3 by 4 of G. From here it is G. Okay. And T of liquid, sorry, that is root G. Okay. Just a second. Just a second. I have to delete this thing. We are getting G effective is equals to G1 minus rho liquid upon rho material. So G, given that density of the liquid having 1 by 4 times this material, 3 by 4 G. is G of liquid. So T of air upon T of liquid is G of liquid upon G of air. So G of liquid is 3 by 4. G of air is this. So 3 by 2. We want to calculate the time period. Okay. Then we will cross multiply this thing. We have given the root 3 seconds of the air. So we get the answer here is 2 seconds. Simple concept, that is inverse proportional to the root of G effective. These are the formula based questions. Now next question is what is from the electrostatics, that these are the four charges minus Q plus 4Q minus Q. Distance is D, whole distance are D. For minus charge, the direction of electric will be inside from charge. This will be direction will, and for this positive charge, the direction will be, we want to calculate electric field at this point D. We know that for the, suppose even from for this charge E1 and for this charge E2, we know that KQ upon R square. We know that formula of electric field. So for this, we get KQ upon D square. And for same this, we get KQ upon D square. And we know that this diagonal will be equal to root 2D. So we get K 4Q upon root 2D whole square. Then we will get K 4Q upon 2D square. That is 2KQ upon 2D square at this outward direction at this point from this charge 4Q. So even if it will be in this diagonal direction. So this resultant will be equal to this resultant will be in this direction. So this resultant will be equal to E1 square plus E2 square plus 2 E1 E2 cos theta. Here theta is 45. So cos 45 is 1 upon root 2. So E1 square is KQ upon D square whole square, KQ upon D square whole square plus 2 KQ upon D whole square 1 upon root 2. We get from here root 2, we get 2 plus root 2 KQ upon D square. Okay, then we know that this is outward direction, this is inward direction. So we will have to subtract these both electric fields. Then we will get the resultant total electric field. This net electric field E net is equal to E1 square plus E2 square, sorry, E1 square plus E2 square plus E3 plus E3. So E1 square K2 upon D square, K2 upon D square, root plus E3 is, we have find out this. And the resultant will be in this direction. This is I cap direction given, this is J cap direction. So this is the resultant. This resultant will have the unit vector Ij upon root 2. So this we will get when we add all this sum. Now next question. Question number 41. Following figure show the network of the 6 resistors, each equal to the 4 ohm connected to a battery EMF of 18 ohm having a visible internal current drawn from the battery of the circuit. Simply we have to find out the current from the circuit. See, these all the resistance, these 4 ohm are connected in the series. So how becomes the 12 ohm? That will become 12. What happened to 10? 12. That becomes 12 ohm. And again, these three are in series, so again it have 12 on. So these 12 and 12 are in the parallel. So 12 by 2 is that will be equal to the 6. So you know that V is equals to IR. V is equals to IR. So from this we know that we have given here the value of the V, that is 18 volt. So 18 upon 6 is equal to the 3 ampere. Now next question, question number 42. The current loop having the two circular arcs joined by the radial lines, it carries the current of 10 ampere. The magnetic field at the point O is close to. So for the angle theta, this R, we know that this magnetic field is given to where my pen is not talking.